Hi, today I'll talk about some strain engineering and the reason why we should use some high K gates and the oxide. As we've learned before at the short channel effect part, uh, there are some voltage saturation, even though the electric field gets higher and higher. Because of this, we should see the material at the view of the effective mass at the K diagram. So because as the silicon is on diamond structure lattice, uh, we can see the EK diagram like this, and we could separate some electrons or the holes because it's diamond lattice by the strain engineering. As we can see in here in the picture, as the curve gets poorer, it means it has some high effective mass, and when the curve is sharp, it means there are some low effective mass particles or materials particles, yes. And so we should get some more electrons or holes at the point of the curves and sharp curves. To do this we use some uh we use some germanium to uh, on the hot get some stacks so that we can separate some electrons or the holes which way we want. mm, like this. And for the strain engineering, we use for strain engineering there are global engineering and the local strain engineering, but global engineering is not that good, so we use local strain engineering. And there are three types of local strain engineering. The first one is the rise source and drain, and the second one is the CISL, which means the control edge stop linear. And the third thing is the is this the stress memorization technology, which means we get some stress in the source or drain, and the source and drain memorize that drain and can something like this. The next thing we learned is why we use on high K material. The very important reason is because of the tunneling. As the oxide and the oxide gets thinner, there are some tunneling like direct tunneling and the Fowler Rodenheim tunneling, which tunnel which Fowler tunneling is caused by the electric field, which seems like this. Like as the electric field gets higher, the slope gets has some more curves, which seems like the electrons could get tunneled more easily. Uh, like in this graph, the tunneling issues is becoming higher and higher. So to stop this tunneling, we use some high K materials so we can stop the tunneling. Next time we'll talk about some high K.